Yeah. So what do I need to multiply by that doesn't ever change anything?
A reciprocal or 1.
1.
Yeah.
So I need to make a 1. So if I multiply that by 2, I also need to multiply by what number to make sure I'm multiplying by 1 instead? That's all we're doing. It's not any more magical than that. There's no deep and profound meaning here. We're multiplying by 1. Okay. So now I got it set up ready to U it. So I'm going to go ahead and U it. U to the 1/2, negative 1/2, du. Got to change my bounds. I plug a 0 into this. What do I get?
Plugging a 0 into that? 0? No, 1.
1. I plug a 4 into that.
You get 8, 9.
9. 1/2. U to the 1/2, divide by the power I get, plus C from 1 to 9.
That goes away.
So this becomes U to the 1/2 from 1 to 9, which is 3 minus 1, which is 2.
Well, wait, how did that?
I had a 1/2 out in front. When I raise the power by 1, it's 1/2. Divided by the power I get, which is also 1/2. So 1/2 divided by 1/2 is 1. I tend to flip and multiply. After you've done this about 50 times, you know you're going to flip and multiply it anyways. Yes, ma'am?
I don't know what to do on 79.
That's fair. What's the ugly part?
That's the question. I thought it was 2 minus x. But then when I did it, I was like, well, when I'm doing my view, how do I get x minus 1 if I can't add subtract? I can't.
Yeah. So you go ahead and go on to do 81. And then the rest of the class will catch up to you, and we'll talk about 79. Because 79 is gotta, has gotta, would have a, it is a, something like that, a problem, yes. 79 is a slightly different, not a slightly different problem. 79 is a sizably different problem.
Mr. Is he on 77?
Yes.
Which one's the ugly?
I'm going to guess the thing in the parentheses.
Would it be that whole expression, or?
No, I'm going to guess just the 1 plus root x in the parentheses. That would be my guess. Could I be wrong? Yes.
1 plus root.
1 plus root x, yes.
Okay.
Then something magical happens that you don't expect. Hopefully, you'll recognize it from outer space. But you might not. Oops, I got to pause this. Hold on. Running off paper. No, that won't work. You got it. You got this. I know. Was it 1 to what number is that? 1 to 9?
1 to 9. 7 to 8. 6.
All right. Got to integrate this thing. How do I integrate this?
Just flip it over. You turn it from a fraction. You do the inverse or whatever it's called. I don't know.
Oh, you want to rectify the roots. So I got x to the negative 1/2.
Yes.
I've got 1 plus square root of x to the second
Can't
power.
you do x to the
dx.
1/2 to the negative? Wait, negative.
I can do. You want me to do that? Oh, it should be negative also.
Yeah.
And then I can also change that variable because that's fun too. X to the 1/2. I love it.
It was just making me feel bad. Okay, that's what.
We're eventually going to have to fix that anyways. All right. All right. So moving forward, what is the ugly part?
The ugly part. Let's just say it's the parentheses.
Let's start with the parentheses. See if that works. If it doesn't work, we'll try something else in a little bit. Du equals 1/2 x to the negative 1/2, right?
Yes.
With me so far. All right, so now I'm going to go this way. I got the integral from 1 to 9. Now, actually, I'm going this way, right? From up here. So I've got, this is my ugly part, so I'm going to put that out in front, like I normally do. I got back here x to the negative 1/2 dx. Okay, how do I fix this so it looks like this?
You do the fraction thing. And
What do I need?
See, that's where I'm kind of stuck.
Okay, you literally need to take this right here and put it right there.
So we're not trying to get rid of the x to the negative 1/2.
Why? Because I need it.
Guess you do.
Yes, I do. I have to have it. By the way, if it's not there, you can't do this problem.
Multiply by 2.
So I'm going to put a 1/2 in front, which means I have to multiply the whole thing by 2. Or 2 over 1, whichever makes you happier in life. Don't care, as long as you do it. Both work. Okay, clean it up. So I'm ready to go. One thing is 1/2, -2, 1/2 x to -1/2 dx. Is everything ready for you to be viewed?
Wait. Yes.
That's du, right?
Looks right.
That's ready to go. That's u. Have to fix my bounds. Other than that, I'm good to go.
Yep.
Plug a 1 in. 1 into this expression here. What's the square root of 1? 1. 1 plus 1 is 2. Love it. Plug in a 9. Square root of 9 is
3.
3. 1 plus 3 is
4.
4.
Nice.
Integrate away. Raises power by 1. Divide by the power I get. So this is -2 over u from 2 to 4. Holding on. That's u to the negative power, right? So the negative goes out in front. That's where that negative came from. And u to the -1 is 1 over u. Put it back where it comes from. I don't even see it. When I got bound, c always falls out. So it's going to be something minus something, and the c is going to be c minus c, so it always falls out. Not yet. I got to put the numbers in. Put in a 4 minus put in a 2. So this becomes -1/2 plus 1, which is 1/2. Okay, Mr. Cleary?
Yeah.
Getting better? All right. Everybody try the next one and fail at it so we can talk about it. We'll see if Mr. Reddy can do it this year. 50-50 chance. Well, clearly, then u must be x minus 1. So I try u equals x minus 1, I get du equals 1 dx. Isn't that great? So then I set this up over here, and I've got x minus 1. And then I've got 2 minus x to the 1/2 dx. Anyway, make this look like this. That's even worse. So then I start to struggle, and then hopefully this very moment will occur to you. This very moment will occur to you. Because this is doable. It was doable after the first little bit. Let me show you how. I'm going to go ahead and get rid of this. I'm going to do that. Let me get rid of this. And I'm going to say, Kirkland, what do I have to do to make the back end look like -1 dx? The answer to the question is, I'm just going to put the -1 in there. And you're like, okay, that doesn't help me at all. But I'll show you how it does in just a moment. 1/2, and I got x minus 1, -1 dx. Now put a -1 there, put a -1 out in front, right? Now at this very moment, you should be Mr. Resney, you have not succeeded because although this is u, and this is du, what the heck am I going to do with this x minus 1 in the middle? The answer to the question is, actually, I'm not going to go that bad. If you have to go to another variable, this won't work. What I'm going to do is this. I'm going to say, well, what is x in terms of u? What is x in terms of u? So u minus 2 equals -x, right? Come on, stop selecting things. Okay, and then therefore -u plus 2 equals x. Agreed? So what if I were to try, in desperation, to plug that in here for x? I mean, in desperation. Probably not going to work. Well, it's going to work because it's set up to work, but this should be a desperation move. You should be like at the end of your rope going, oh gosh, now what else do I do? Oh, I'll try this. What the heck? 1/2, this is negative u plus 1 du, or negative 1 du. I still got to have this negative 1 here. Now, can I distribute that through? I can now distribute this through, can't I? Now it's set up so I can distribute. The negative, this would be 3/2, right? Oh, I got rid of the negative. That's why I didn't need the negative 1. I apologize. Let me back up. I'm making a mess of things. This is du, this is du, this is du. Right? Kirkland, okay? Let me back up a couple steps. So what happened was we got to the point where we just couldn't do it. We're like crushed, sad. We tried both ways, nothing worked. Then we recognized, well, maybe I can take this extra expression that I don't like and make it into a u by figuring out what x is in terms of u and plugging it in. Once I do that, then I got to hope that this thing resolves itself in a way that I can actually take the integral anyways. Because remember, as long as there are two things multiplied, I'm dead. I can't do it. But sometimes, if you're lucky, you get a situation where you can distribute or something like that. Okay? All right? I forgot to change the bounds. Darn it. When I plug in a 1, I get out a 1. When I plug in a 2, I get out a 0. Raise this power by 1. Divide by the power I get. Raise this power by 1. Divide by the power I get. Minus sign out in front. From 1 to 0. Plug in a 0. 0 plus 0 minus. Plug in a 1. Isn't there a minus on that 2/5? Is there a minus on 2/5? No, there isn't. Yes, there is. That should be a minus. That should be a minus there as well, right? Messy, messy. 15, 6, 10. Negative 6 plus 10 over 15. Negative 4/15. All right, so again, the only thing that's really new here is that occasionally what you can do is try to, if nothing's working, try everything first, right? You're more likely to have an ugly that you missed than to have a situation where you can replace both. Okay? Oh, what did I do wrong?